The topic for now is output table. And what are output tables? Well, in other words, are just it is just the output that you get from MaxQuant. As you can see here from this simple representation, we have our raw data, the output that you get from the mass spectrometer. You analyze that with MaxQuant, and then you get a result. You get some information about those raw data that you analyze. And output, these are output tables indeed. And they are like the link between MaxQuant and Perseus. Usually, then you want to analyze and you want to represent your data. So your output table, you can use Perseus, you can use also whatever you want. If you prefer R, if you prefer Python, and everything. And then you do further analysis on your data and then hopefully find good results. But you don't have in output table only the information about the results that you get, but you have also further information that will help you in understanding how good your experiment was, and also if MaxQuant performed as expected. Well, let's see here. Like, for example, this is an output that you will get from MaxQuant. You see, you have the name of your experiment. Then you will see that you have several folders inside this folder. They, for example, if you dig into this folder, you will see for each mass spectrometer run that you fed to MaxQuant, you will have then the Andromeda scores, the peptides that has been recognized, and every kind of information. But usually what you want to check is the combined folder. And inside you will have different TXT files. These are tab-separated files. So remember, if you want to import them in R or Python, don't use the import CSV function, but use the import TSV. You can also open them with Excel if you want to look at them. And fortunately, in case you have any doubts or you're not sure about what you're seeing, there is a PDF file where you will have that. Here you cannot see very well because it's small, but there is a description of everything that you will find inside the folder. So if you have any doubts, just open the table PDF and everything will be described. All the things that you will find in the combined folder. So as I said, you can open the output tables with Excel, but I mean, you can do this if you prefer, but what we recommend, and also what you will see in the next days, it is opening them with Perseus. So you can have here, you can see your information, what you get from each replicate, each experiment, some further information here about the peptides, about the protein group, about whatever. So you will see, I mean, this is exactly what you will do in the next days. You will open some output tables in Perseus, and then you will do the further analysis. But not only in Perseus, you can also visualize them in MaxQuant. And there is this button here called Visualization tab, indeed. As you can see here, you have, again, the table with the information, and then here, a graphic representation of your data. You can see here, for example, the M/Z with the retention time and all the peaks. You will see more about this graphical representation on Friday. Will be the last talk, and will be MaxQuant viewer. But what are output tables exactly? So here we will zoom this part, and you can see there are 4 different groups: scans, identification, features, and metadata. Well, scans are the output from the mass spectrometer, peaks and everything. Usually, I don't know which kind of experiments are you interested in or what you're going to do, but usually these are data that are more interesting and important for people that actually use the mass spectrometer. If you want to check how your mass spectrometer performed, if you find the correct identification window, for example, if you're doing some kind of experiment, you go here and you can see then the peaks and the outputs from the MS1, the MS2, and the MS3 also, if you have done that. But these are like very raw data. If you want also to still find information about how your mass spectrometer performed, you can go into identifications. Generally speaking, identification will give you information about signals that has been identified into peptides. So what are we going to have in identification? We have the protein groups, protein that has been identified. We have the peptides that has been correctly identified with also their Andromeda score, with also all the information. So you can see also how good was that peptide identified. But we have also information about the modifications, post-translational modifications, and evidence. And then also, as you can see here, also information about the msms, how it performed. But evidence are peptides that signals that were coming from the mass spectrometers that has been correctly identified into a peptide. But as you can imagine, you don't have only a signal that has been identified into peptides. You have also other stuff. And these are the features. Here you can find every signal that came out the mass spectrometer, and doesn't matter if it was identified into a peptide or not. And for example, from this information, here you have all the feature and the matched feature. Matched feature are those that were indeed identified, also considering the FASTA file that you gave to MaxQuant. Here, for example, you can visualize how good, how many peptides you identified from your mass spectrometer. If you see that a very small percentage of all the data that your mass spectrometer your mass spectrometer gave you, well, maybe something went wrong. Maybe there were too many contaminants, maybe, I don't know. And then lastly, we have the metadata. Generally speaking, here, the metadata is just, you have just a summary of all this information that I showed you before, that I told you right now. And then you have also the parameters. Could be useful if you want to, these are the parameters that you used in MaxQuant before pressing start. It's very useful for people that want to replicate your experiment, or if you want to then in the future, then check again what you did. So generally speaking, all useful information, but most of the time I will say that I don't know what you're going to do, in specific, but most of the time I will say you will be interested in this. These are the biological information. I'm not saying that the only interesting information, but the most interesting one. Because here you see the proteins, you see the modifications and everything. Usually you will then analyze the output from identifications. So what we have? Let's start with the most basic one, protein groups. So you will have, again, a CSV file, a table. You will have the information about the proteins that were, which protein group was identified. You have then also several other information to let you know how good that identification of protein was. So you have, for example, how it was identified, if with the proper MS1 and MS2, or if it was like identified only thanks to MS1, and then an MS2 coming from another experiment. You have the number of peptides that allow to do the identification, the coverage of your sequence. So you put together all the peptides and you see how good the coverage was. You have the Q value. So how good was that identification? But you may also have information about the quantification, like the intensity, the LFQ, IBAC, if you want to do that, normalized ratios, and then TMTs. This is how it looked like. I mean, from here, again, you cannot see very much, but yes, I mean, it's exactly what you expect. Columns with every one of those names that I said before, with their respective numbers. And then on the rows, you will have the protein groups. Then you have also, if you're interested in post-translational modification, you will have also the file that will give you the information about post-translational modifications. right? And then you will have the further information about the probability of the localization, number of modifications that happen in that particular site, and then also information again for the quantification. So again, as I said, output tables are the link between MaxQuant and Perseus. And usually these two output tables that I showed you are those that, generally speaking, you would then use for Perseus analysis. And also those are exactly those that you will use in the next days in the tutorial for Perseus. But then there are also several other information, and as you remember from Monday talks, you start with the protein groups, but they are coming from peptides. But actually, peptides are originated from evidences, and evidences are just the mass spectrometer outputs, the peaks and everything that were you output from the mass spectrometer. And then, as you can see here in the identification group, you will have all information about this if you want to dig into your data to see what actually happened in the MaxQuant run. So let's start with peptides. What we have, well, the sequence, basic information. I want to see which sequence it was. The score, how good that sequence was identified. And then you have information about the mass, length, the number of amino acids, which amino acid, which is the first and last amino acid. Could be useful. We will see that after. Then also the cleavage, where it happened, and then some information about like protein, for example, where this peptide locates in the protein. And then, of course, about quantification. Again, we have intensity, ratio, and everything. So why we could be interested in the peptide length? Well, usually they are around 8, 10 amino acids length. But if you have something that really diverges from that, probably something bad happened. So you can use the peptide length as a general quality control of your peptide identifications. Then, but you can use also the miscleavage rates. So we usually use trypsin. So we expect the cleavage to happen in these two amino acids. But it may be that also the miscleavage happened. And if we see something like this, we can say, okay, there has been some miscleavages, but there were not too many. Could be reasonable result, this, but if you instead have something like a way higher number of miscleavages, probably something bad happened during the preparation of your sample, or most likely also during the MaxQuant run. So this is a general information to see how trustful are your results. But then we have also where it locates in the protein, the peptide. So we have the start position and the ending position. And we can see here from this graph, this is a general coverage of a protein. They are linear. They most likely start in random location. They start and end in random, mostly random locations in the protein. So you can say from here that you had kind of a good coverage of the protein. But we may have something like this here. Then is log. We have the log intensity of the starting position only. As you can see here, we have a random starting position in the first half of the protein, but then here there is a much higher intensity for the second half of the protein. Why? Maybe something happened in the experiment, or maybe you were just looking at two different isoforms of the same protein, or maybe it was a protein that gets degraded in a particular way. It's cutted, and then the two parts are degraded after. So it could be an error, or it could be also useful biological information about your protein. So again, this is something to check your peptides and to check the quality, or to check if there is something actually interesting happening in your experiment. Again, it's a simple Excel table that you can visualize, again, as I said, also with all other programs that you prefer, and in Perseus as well. You see here your sequence and all the information that I said before. And also, as you can see here, there are the different experiments, so you can check like the starting position and the ending position for every single experiment. So yeah. And here, sorry, and here there are how many peaks contributed for that peptide, for that particular peptide. through all the experiments. So it's a good way to check if there were some batch effects happening in your experiment. Again, here to recap again, we've seen peptides. We will go now to evidences. I guess you got tired right now of this image because you've seen it on Monday and Tuesday, but it's good to recap. So what is a feature or an evidence? This is a feature or an evidence. The information, the peaks that you have, then will be used to identify then the peptide. So we have the evidence file also. So we have all the information about this tridimensional shape. And we will have information about the different charge state, for example. If your evidence were not in a normal, +1 charge status, but a different one, if your signal was identified into a peptide and that identification required a modification, for example, then you have also the mass error, the score, how good it was identified, and then information about the retention time. And you remember also there was the problem with the recalibration of the retention time in different experiments. You have here. All this information are here. And here you can use this Evidence.txt file to then check how good it was, your evidence, how good and reliable were, then to identify peptides after. Again, here we have the table with all the description. We will go into that now. Retention time. Here we have, of course, in this table, you have the retention time uncalibrated, because if you then want to check a calibrated retention time, it will be a line because it's been calibrated. Here, you want to see how it was before calibration. So if something bad happened in your experiment, in your different experiments. So we have here, for example, uncalibrated mass error with along the retention time. It is wobbling, but it's just a normal error that you can get from the mass spectrometer. So we can say that this could be a reliable mass error distribution, but we may also have something like that. And well, here something really bad happened during the mass spectrometer run. Maybe a batch effect. Maybe one day the mass spectrometer was doing something really wrong, an error, or I don't know, you just opened the door while you were running it, and then that skewed completely the results. I mean, you know, definitely, if you use the mass spectrometer, you definitely know more than me, because I never use one, but probably know how, I mean, how many factors can impact that. And here we can see from this. So probably this data, even if you will recalibrate them, and then they will be on a nice line, or the mass errors through the retention time. But you can also understand that MaxQuant changed drastically this information in order to recalibrate everything. So if you have an uncalibrated mass error at the beginning, something like that, maybe it could be a good idea to redo the experiments, if it's possible. Then what we have, we can check, for example, different retention time. You remember then when we were talking about identification and quantification, you may have differences in retention time across different experiments. And yes, we would like to have it like that. And again, here we're talking about something that is happening before the analysis in MaxQuant. So when you have evidences here, this information were done before all the pre-processing that you saw during Bailey's talk on Monday. So these are like very kind of raw data, and you check like the general output from your mass spectrometer. But for example, with the retention length, you may have something here. Imagine that these are 3 different experiments, and you have something like this. There is one experiment that is completely different compared to the others 2. And what happened here, we don't know. Could be probably a good idea, again, to check and redo the experiment. As I said, this is a general quality control of your data. again, another quality control we may have, how these evidences were, from how many MS2 events these evidences were identified. So we expect 1. So it means that you started with MS1, you went to MS2, and then thanks to the information that you got from MS2, you identified the peptide. Basic, normal, as we expect. But you may have 0. So this, if you remember, you can use the information for another experiment, so you can just use MS1 information. When you see that they match together, you can then take back the information of MS2 from one experiment and use it for your next experiment. And this means that we're identified by 0 MS2. But then we have some that has been identified by 2 MS2. And this cannot be possible, actually. It is an error. It means that you have 2 different data, so 2 data that were not calibrated, that led to the same peptide. We expect that we identify the same peptide. We should have an exact, the same MS1 and the same MS2. But here, if instead we have 2 different, in your 2 experiments, you had 2 different MS2 that led to the same peptide. It means that they were not calibrated and they were changing the MS1 signal from the beginning. So this is an error. It shouldn't happen. Okay, now let's go quickly into scans. As I said, these are more, I mean, this information about MS1, MS2 can be are summarized in evidences, in msms, in identification. But here, then you can more dig into like the shapes of curves and everything. They're not just numbers. You can more look into your data. And again, this probably would be something that you may use if you're more interested about more experimental setup of the mass spectrometer. Unfortunately, I'm not, as I said, I'm not very an expert about mass spectrometers, actually not at all. So yeah, probably you will know more about these specific things than me. But let's go. Then here, as we can imagine, we have MS1, MS2, and MS3 if you've done that. But usually these are not data, these are not output tables that you will get normally when you run MaxQuant. You need to check this box. When you check it, then MaxQuant will give you also the information about these MS runs. But normally it is unchecked. So if you're specifically interested into this, check it, and then you can look at your data. How they will look like was something like this, for example. Here we have a window of time, of retention time, that was used to identify an MS1 signal into an MS2. That was used, sorry, for the MS2 and then for the peptide identification. And from here, for example, if you, I don't know, maybe if you're interested in targeted proteomics, or if you're interested to see a specific window of identification, you can then check this data and see, okay, in order to maximize the number of correct MS2, I need to select a window that is going from here to here. And then I can say precursor apex fraction that will lead to a successful MS2, 1%. So if I take a length here on this peak, I have the maximum probability of having a successful MS2. But for example, you may want to have a wider window. So, but then you also go down with the successfulness rate. Or you can also select like a window that you have, you want to discard completely. You know that after these 2 points, you don't identify anything. So you can remove the data from before and after if you're interested in that specific MS1 signal. We can do also the same thing for fractions. We have here different fractions, and we see that we got some good signals from these fractions here, and then after nothing. So if I am specifically interested into that into that peptide and that protein, maybe I could just then select the proper fraction to have the maximum identification. And surely it's not going to be here. As you can see again, we have the percentage, the probability of having a successful MS2. So we can take here the M over Z number to then see where it would be more successful, where not, and so on. These are, as you can imagine, these are more, I could say, experimental information, more useful if you're really using the mass spectrometer, if you're more interested in the experimental setup rather than the data analysis. Another example why we can use this information is then you may want to see in your window where your targeted ion is located, and when, for example, another contaminating ion is located. As we can see here, we have a isolation window where there was the proper ion identified, selected, but then we had also some noise coming from a different ion. Why it could be useful? Well, then you definitely, this is a kind of information that you are going to need when you would want to do a proper TMT labeling. So you want to find proper isolation windows and be sure that you're not isolating something that is not supposed to be there. Another thing that we can check, for example, we know that we have a signal from MS1 and a signal from MS2, right? And MS2 is coming from MS1, so the sum of the peaks from MS2 should be the same, or at least similar to the original intensity of MS1. But here we don't have it, so something something happened here. Or like, for example, we can see here we had a higher intensity. This is precursor ion. Okay, so we have a higher is going toward MS1. Here, MS2. They should be on this exact line here. So it means that, for example, something happened during MS2 and you were identifying more stuff, more contaminants, more something that was not supposed to be there, or maybe something bad happened when you were doing the before MS1, when you were doing the liquid chromatography. So maybe you want to put less data in your mass spectrometer when you see this kind of stuff. Lastly, then we have the features, as I said before. Let's go again here and back to this image once again. Features and evidences are the same thing, are this. But evidences are these informations that has been translated into a peptide. Features are all of them, also those that were not identified into a peptide. So what we have in the old features.txt file? Well, we have exactly the same thing that we have in evidences. So we have M over Z, charge, intensity, retention time, and peaks. But why we may be interested in this information is, like, for example, we can see from here that we have all these features that has been analyzed in this experiment. There is only a very small part of them that has been targeted for MS2, and an even smaller part of all of them that has been correctly identified. Well, this could be because there were so many contaminants in your experiment, or because something happened, or maybe, you know, this could be something you may really want to look at if you're doing, when you're analyzing different species together, or especially when you're doing proteogenomics. So you can see very well here how good was your identification for species specific. And then you can see, like, how many were the features that led to a peptide, how many were those that were not used, and then look for why they were not used. Maybe I was missing a library, and maybe they were too short to be identified. Maybe they were just contaminants. And lastly, we'll go here to the metadata. So it is just a simple summary of all the things that I said before. So, for example, you can see here, we have our raw file that says, okay, then there were all these informations about MS1, MS2, peaks, evidences, features, protein groups. It's just all the information summarized in a single table, if you want to recap everything. And as I said, also you have here parameters, the parameters that you use for your maxquant run, so that then you can repeat the same experiments, or you will make life easier to other researchers that want to replicate your experiment. And then you have the range of mass over Z, the general range. And yes, I mean, as I said, this was a kind of easy, quite relaxed topic to start. I mean, there is nothing fancy, nothing really to understand, just names and stuff. So now you know more or less what you have in the output tables.